I talk very quickly, and I know this, so I'll try to remember to slow down, but as soon as I get excited, I'm going to talk fast. Don't be afraid to ask me to repeat myself. There is going to be a recording too, so you can see some of the things up there. I don't have slides today, but I have a couple other things instead. I have some stories, I have stickers, I have source code, and I have observations, which I couldn't fit with the S theme I had going on, so I had to lose the S's that I was doing. There's going to be a lot of things I'm going to talk about. We're going to talk about the cybersecurity industry, community, ecosystem. I've worked on several sides of it. We're going to talk about AI. We're going to talk about reverse engineering, decompilation, intermediate languages, whatever you guys are interested in, too. This can be very interactive. I hope it's interactive. I would like you guys to ask questions. Good questions get extra prizes, right? So stickers are for everyone. I have stickers for everyone, but the good prizes are for good questions. So just keep that in mind and keep track of yourself. If I get good questions, I'll tell you, grab a, and so there's pens and little Binary Ninja pen holders that go in your notebook. They stick in, and you can put the pen in. There's only 5 pens, unfortunately, because the other ones, oh, there are some pins too, little cute little logo pins. All right. So, and also at some point, I'm going to just stop and make you ask a question too. So just be prepared, like queue up some questions. I really do like interruptions. I like questions. As Jiska said, I make Binary Ninja. I'm one of the worst developers on the team making Binary Ninja. And I don't mean I'm a bad developer. I'm just the worst on the team of people that are doing it. And I know that. That's why I get to go give talks. And they're all fixing bugs and writing new features. So I'm very happy to work with them. Before I go on and talk more about me, because there's going to be a lot of me talk, which I don't always like to do. But I think there's a lot of fun stories that I have to share. I'd like to know about you. So if any of these things apply to you, raise your hand. If you've written C, any C source code, fantastic. Keep your hands up if you've written C++. Keep your hands up if you've written Rust. Oh, okay, so we're getting there. But how about, how many have ever decompiled C? Okay. How many have ever debugged C, run a debugger of any sort, GDB? Everybody who's written C has debugged C, okay, or else you're lying. So let's be clear. Those usually are the same. That's a trick question, right? Okay. How many people have written a decompiler? Yeah, very nice. Which language?
What do you mean? Which assembly set? Or?
So yeah, were you decompiling particular architectures like a Python, .NET, native assembly?
Just decompiling regular x86.
Yeah, fantastic.
I'm missing some instructions. But
No, x86 is the worst one to start with. Start with ARM or start with RISC-V or anything else but x86. x86 is the worst. I have a chart on a different slide deck which shows the total number of opcodes per architecture. And depending on how you count them, there's like thousands of x86 opcodes. So that is absolutely the worst one to start with. Okay, how many people have played Capture the Flag? Nice. How many people have like run a Capture the Flag and made challenges for one? Even better. All right, cool. Is that all my questions? Yeah, that's the last. Oh, how many people have written an exploit? CTF exploits count. I'm not saying it doesn't have to be. Yeah. If you've written it, yeah. Have you gotten classes? That okay? Good. All right. Well, you guys are a good audience. You've got a lot of this stuff already done. So I started my career in security in 1996. I'm older than I look. And hopefully, or else it's, oh no, if it's caught up to me, that's bad. I assume that. I started actually selling dial-up internet in a mall. So you would walk up to a kiosk, and I would sell you a dial-up internet connection. It was before like broadband was a thing back in the United States. And so I started like just like a help desk thing there, and I actually even got a raise because I actually understood how like computers work and modems worked. Anybody like ever know the joke about like ATH in like chat messages, like an IRC, you type like ATH++, because it was actually a modem command that would disconnect your modem. And depending on like how the echoing would work, if your modem would echo back messages, it would just literally disconnect. So you'd send this message and like half the chat room would log off because their modem is disconnected, right? And so like this was, I think, a really cool, it's a funny prank, it's an old joke, but the thing that it points out is an issue that's still here today, which is when you're mixing data and control, right? Like data which is things that we operate on, and the control, the operations that do the operating on the data, right? Those operations, you normally would keep those separate. SQL injection, command injection. These are all examples of mixing data and control. And of course, we're cursed with our computer architectures, most of them, where we're mixing our data and our control, right? Like there have been Harvard or non-Harvard, I forget. There's like, the architectures that actually designed from the beginning and said only code can go in this region and only data can go in this region, and you cannot mix the two. And they're way more secure. But it turned out, like early in computing, people were cheap, and if we just had one big block of memory and we could use some for code and some for data and some for heap and some for stack, it was just cheaper. And so that's why that architecture kind of won, and that's what we see in the vast majority of all our modern systems, and thus we all have careers in cybersecurity. Well, one of many reasons, right, we have careers, right? So dial-up internet. I worked for Gateway Computers, where actually I did tech support on the phone. So people would call up and be like, my cup holder's broken. And we're like, your what? My cup holder is broken on my computer. And we realized they meant the CD-ROM tray. Like you would push into the CD tray, would slide out, and it fit their mug perfectly. So like an actual call that I didn't get, somebody else in the call center I worked in. Then I worked for the University of Florida. I did network security, and this is where things started to get kind of interesting. So I actually got like a real security job. I had a server I was setting up as a student. I ran, I was doing IT at a department. I set up a print server on Red Hat 5. Not Red Hat Enterprise Linux 5, like Red Hat 5. This would have been like 1999. And that was back when you set up your sound card. It would be, my name is Linus Torvalds, and I pronounced Linux, because people had said Linus and Linux would miss the pronunciation. And so like back in the day, that's how you knew your sound card was working. So I set the server up, and somebody immediately hacked into it because there was no patches, and I was an idiot. I didn't secure the machine, and it started sending spam emails. And the university had just hired like their first full-time security person, and so she had got a notice from somebody else and sent the notice to my department to you got hacked, and so we unplugged the server, and I was so excited. I was like, hey, we got hacked. This is great. What happened, right? And so I went and I did a report, and I found out the exploit. I did a little bit of forensics, and I wrote it up for my boss. And I didn't know, but he sent it on to the security person at the time, and that turned into me getting hired as the first network security engineer at the university. So I got to play with all sorts of network security devices, right? So monitoring the network, doing forensics. And then I was like, yeah, this defense stuff is fun, but what would be way better is if I could exploit stuff. That would be really cool. But I was always too chicken to illegally hack things for the most part, certainly when I could get caught. And so I started playing Capture the Flag. I started playing these CTF events, right, which I think you take for granted nowadays. That wasn't really a thing that everybody was aware of, that everybody did. There wasn't a CTF every weekend. There's 4 this weekend. I looked because somebody just announced on CTF time, hey, CTF time, my CTF isn't showing up. And it was because, whatever reason it was slow. But I was like, why would you do that during DEF CON Quals weekend? That seems like a poor choice to overlap with. And I was like, well, there's actually B-Sides, San Francisco, and several other ones, right? We have so many opportunities to play Capture the Flag. The challenge. At any point, stop me, and I'll tell you a fun story about something related to what I'm talking about, I hope. I have a list of fun stories that I can get into as time permits. So we'll see. No one's gonna call me on it yet. Okay, all right. No? All right, we'll keep going. And so then I started Vector 35 with a couple of friends, and not a lot of people necessarily know Vector 35. Really, Binary Ninja is the main thing that we advertise, and we're known for. All the stickers say Binary Ninja, not Vector 35. And it's a decompiler. It's a reverse engineering. We say a reverse engineering platform because we want to be not just a decompiler, right? Which sort of implies that you put in bytes, you get source code, and you're done. That's what it does. But we really focus a lot more on the API, on automation, on being able to integrate it into other workflows. So you can use Binary Ninja as a library. You can literally, oh, we're going live already. We'll see if this works too. I haven't checked if let's see which version we're doing. Yeah, okay. So you can just, in a Python REPL, I can open up a file, right? And I can do things on that file without any GUI. I can statically compile the library into some other language, into some other bindings, right? So we really wanted automation to kind of be a part of it. Oh, I flipped my notes closed, didn't I? Oh, this is the reminder. Slow down. See? Slow down. That's why it's there. All right. Okay, so that's kind of like my work history, but then let's step back a little bit, because I mentioned I played Capture the Flag when I was getting into this offensive stuff. That's how I got my job. Although actually, it turns out I actually got hired because I was working for magazines at the time. I was writing like articles for like technical journals on like more product reviews. So I call them like book reports on security products. Like, does HP Web Inspect find more bugs than Acunetics? It's old web, assessment software. And so the company that became Raytheon that hired me, one person hired me thinking I was going to become a technical writer, but they didn't tell anybody else. So I was like, yeah, I'm here to write exploits, and I just like started doing that, and nobody could stop me. So it was great. So I only found out like literally afterwards that was what they were thinking, and I'm like, oh, you should have told me that. And I did some of the report writing, but I preferred the exploit writing instead. So that happened because I'd been playing Capture the Flag, and there weren't a lot of people doing exploit writing in public that could get clearances in particular. And so I kept playing Capture the Flag. Like, I literally have been to DEF CON CTF finals 9 times, I think, over the years. I was real mad when when PPP had more wins and more appearances in the finals than I did, but they have since destroyed that. Like, they are still dominant to this day. I got old and it got hard, and so I stopped playing, and now instead I make them. So if you're familiar with Pwn Adventure, actually, how many people have heard of Pwn Adventure? A couple people? Oh, my friends in the front, thank you. So Pwn Adventure 3 was one of them. There's Pwn Adventure Z. My feelings are not hurt if you haven't heard of these, by the way. These are very, very specific. But these are hackable video games. This was an NES cartridge. And we actually made it as a physical NES cartridge at Seesaw, CTF, NYU Poly. Yes, question, thank you.
Did you exploit them using an emulator, or could you actually exploit them using
Yeah,
hardware?
good question. Get your pen. And the answer was both. So the way that we did it was, and this one in particular, when students showed up for the Capture the Flag, we said, welcome, here are 6 of your challenges. And we showed them their NES cart with their team sticky note on it. And we told them, you've been given that ROM to emulate locally, but all the flags have been masked off. So you can test it in an emulator. You can build up what you're going to do. But every flag in the game was solvable with just including code execution, right? Like the last flag, you literally had to get code execution on the NES using like item manipulation. So the full like speed run AGDQ style. In fact, we actually went to, anybody familiar with AGDQ or SGDQ? Awesome Games Done Quick, Summer Games Done Quick. It's a very cool speed running event. We got to go sit on the couch and have our game be sped run. They were speed running our game. People were really confused, though, in the speed running community. They're like, wait, what is this? This was a game that was made to be broken? I don't understand. They were confused. So the audience didn't quite follow along with it. So we gave them the cartridge. Well, we didn't physically give it to them because I was worried about somebody just dumping the ROM off the cart, right, and getting a cart dumper. But like they would come up and they would sit down at it. We had like CRTs. We actually got old school like TVs just to get the best picture, because the new like HDMI just doesn't cut it. You got to get the good stuff. We actually were like on Craigslist finding like these really ancient TVs just to like to collect them. And then yeah, you had to like solve it. So there were like 6 different flags. Some of you had to do glitches. Some of them you could a couple of them you could get just playing the game. Like just by doing enough things, you could unlock 1 or 2 of them. And it was, I think, an actually legit kind of fun game. But yeah, so there's a whole series of these hackable games. We have a new one. Rusty's working on a new one. So my company was founded by 3 people, me, Peter, and Rusty. Rusty is by far the smartest one. He's the one that like did all the hard problems in Binary Ninja. He's the one who did most of the engine that we used. Like Peter and I helped actually a lot with this one, but some of the other games like Pwn Adventure 3. If you're familiar with Live Overflow, a fantastic YouTuber on security content, he did a whole series where he just went through, because he was like, this CTF kit, because we did this at ShmooCon CTF many years ago, which was ShmooCon was a conference in DC, although I think it's last year is this next year, so it's about to be done. But we ran the CTF there for about 6 years, and we ran this game just for one weekend, right, just for the CTF, and it was a full 3D MMO. Do we have video? I think we have some videos of it, but yeah, these are all the videos from Live Overflow of him solving each of the challenges. He went back and was really excited to do it later. So it was a lot of work for 1 weekend worth of game. So I've done a lot, yeah, and then also I've started a thing. Well, I didn't start a thing. Yes.
Did you model these
We did. Yeah, we explicitly did. Some of them were just things we came up with, and some of them were things that we modeled after other ones. So in fact, in particular, this one, where is he? Fire and Ice, exploiting integer overflow. This one was explicitly, I think, a Diablo bug where you could basically integer overflow. There was a boss who would, once you got him below half health, he would heal himself to full health. And he was a fire boss, and so you could do fire spells and you could do ice spells. Fire spells healed him, ice spells hurt him. But you couldn't, like once you got him below halfway, there was no spell in the game that could get him down fast enough to go all the way down to 0. He would heal himself back up to full health before you could do that. So what you did was you healed him below half health. He healed himself, and then as he's healing himself, because it was like a 5-second wind up of he's like starting to heal, you would spam heal, 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 get him back over half again. He would heal himself, and what happened, there was a check on the healing logic, right? And we gave people, like the game logic was in a DLL that they had access to. This one was written in Unreal, so it was C++. And then we did Unity for the previous version of the game, too. There's 2 different versions, which was .NET. And so once you got him above his maximum health, though, you could keep healing until it actually wrapped around. So you didn't see anything, so you had to kind of like suspect that this was a thing, or you could monitor the network traffic, you can extract the data. There were some other hints you could do it, but yeah, you had to follow this logic of, and that was actually a thing that happened in Diablo apparently, was that there was a boss you could kill by healing because you could get past any sort of like max check. So yeah, we 100% did several, and then there were other ones that we actually didn't know. So for example, in the Pwn Adventure Z, the NES game, there was a glitch where if you walked into a room and an enemy hit you and knocked you back out into like the teleport, you know, the sort of like room change transition, like a doorway in and out of a house would change the screen you were on. You could cause this to happen where you could basically glitch out of bounds, and you could be inside the house but outside the house, and you could walk around. It would let you walk like into areas you couldn't get into. And one of the speedrunners that we were like playtesting the game with earlier actually found this, and we're like, oh, that's really cool. They're like, yeah, this is a common technique that we do in game speedrunning. And so we're like, okay, cool, how do we make this a challenge? So we specifically put a flag that you could get by doing that. You would get knocked out of bounds, then you could walk around into an area you couldn't otherwise walk into. Because again, you had to do it all, you couldn't modify it, you couldn't patch the game, because it wasn't in the emulator, you were doing it, right, on device. So yeah, I've played a lot of CTF, and then made a lot of CTF. Like I said, I'm old and slow, and so now I talk about them and I make them. In fact, tomorrow, I hope, I will be commentating for live CTF. I say I hope because we're a little behind, and I have to finish my challenge tonight. But if you go to livectf.com, during DEF CON qualifiers this weekend, 6 challenges are going to be, we're going to talk about during the event. And the way that we do that is, each one is only available for a 4-hour time period. And then once it's done, it's removed from the scoreboard, and then we will come along and like do like a esports cast, like StarCraft 2, like, you know, commentary about, oh, let's look at the exploits and see how everybody solved it, right? So these are a bunch of challenges where you don't give us the answer, you give us your solution, right? So you have to submit like a Docker configuration, and then we run that and we evaluate it, and the fastest team to solve it gets like the most points, but we get to see everyone's solutions, right? And so it was really fun. Last year, you can see we did this during the qualifiers last year. We've also done it 2 years in a row at the finals. That one's a little different. That one's head-to-head, and we're just like HDMI screen capturing 2 people's machines. Yes?
So you basically executing code of somebody breaking into something else? Did anyone ever try to break this submission system itself?
Probably. I don't know if they succeeded or not. I don't think they succeeded because they didn't get points if they did, because we can go back and verify it. It's pretty isolated in terms of what they can do. And the way that it works is we sort of, we instantiate a VM of theirs, and it talks to a VM of ours inside of Docker, right? So they can do anything they want in their VM, but they still have to exploit our server. And so like if they had like an actual 0-day, I guess they could use that, but it'd be way easier to solve our challenge than it would be to write a 0-day or give us free 0-day. I mean, I'll take it if somebody wants to give it to me. That has happened, by the way. No one's asked for a spicy story yet. Not a single one of you. Disappointed. So here's one spicy story. One year at DEF CON finals, there was a team that actually had FreeBSD 0-day. And they specifically used it to escape a jail. So at the time, every service was jailed into its own like low privileged account. And so they would use it to jump out and become root on the box. And so then they could exploit all the other services. Even spicier, the same year, well, not even spicier, but also a fun little bit of spice. That year, my team had a kind of broken proxy that almost worked really well, which is, how many people know that there's a TCP timestamp field in the TCP header? Okay. How many people know what it's initialized to or what its change is based on? You want to take a stab? So, and this may not be true anymore. I haven't actually checked in the last few years because I'm curious if the OSs have changed this. But at one point, it's initialized at boot. So when your machine turns on, it starts with a fixed counter. So it starts at 0 essentially. And then there's a different rate. So certain OSs increment it based on real time at a different rate. So the slope of the line will look different. And if you gather enough points, you can best fit these data points on a line, right? Which lets you solve for de-anonymizing users inside of like a NAT, right? So network address translation. If you have a NAT, which is rewriting all of the IP traffic into like one IP address, you can actually individually identify who is who just from this one particular field, which is really neat. This is important because at the time in DEF CON finals, the way that you would verify that people weren't pulling shenanigans, like if I'm running a server at DEF CON, I just unplug it or put something else there, ta-da, it's secure, right? They have what's called an SLA checker, right? So service level agreement, like in a normal commercial service, AWS guarantees 9.99, however many nines, I'm gonna slow down again, however many nines of service. And that guarantee is because something is checking and making sure it's still working. Well, in the capture the flag challenges, something is checking to make sure that vulnerable service is still there, or it's not vulnerable, maybe it's been patched, but the full functionality of that service still exists. Otherwise, there's too many, we call them Superman defenses, like a generic defense. You just apply a jail on top of the binary and don't let it open the flag file, but let all the functionality be otherwise normal, which is just not fun. Like, yeah, that can work in the real world, but only if you, one, carefully constrain your jail, right? So that's a separate problem. When it's just one flag file, it's too easy. So we don't let people do that in the games via a couple of mechanisms, and one of them is this SLA checker. But if I'm on a network and one IP hitting me is the SLA checker, I'll just allow that and block everyone else, right? So the way that they solve that is by a reverse NAT, or one of the ways that this gets solved, where all of the traffic comes from my router. So if I look at my IP logs, it's just one host, right? Every flow is actually from the same host, from my router's IP address. But we can de-anonymize them using this TCP timestamp field if we have a proxy that can gather enough data and then figure out who is who, and we can predict. And then when a packet comes in, by looking at that field, we can say, oh, yeah, block that one, allow that one. Our implementation was actually a little buggy, and it didn't work super well for identifying the SLA checker. But it did let us figure out who was throwing the 0-day and block just them, right? So two teams had really fun, like, sort of game-breaking ideas that kind of hit each other. And the team that had the 0-day was like, did you guys unplug your stuff? And we're like, no, that's so weird. We went offline. I don't know. But they were like running rampant on a lot of other ones. Okay, what else? So, CTF. You guys can give me another question. I've been talking for a while. What's a question? Any of the topics? Network defense, network offense, reverse engineering, yeah, we'll talk about decompilers and AI and stuff. We'll keep going here in a second. So, fairly, well, if you do it CTF right, you play test internally a lot, right? And so yes, that happens a lot, but most of the time if you're well prepared, not like me in live CTF this weekend, most of the time you've had other team members bang away at it for a while, or at a minimum, you've kind of told them what you're thinking, and they're looking at it, they're like, yeah, but you forgot this, right? So the sort of like fun alternate solutions they happen, and that's actually one of my favorite things about live CTF, is because then we get to see it, right? Like when you release just a super hard reverse engineering challenge and someone just submits a flag, You have to wait to read the write-up. Oh, that's no fun. And you hope they release one. They may not release a write-up. So yeah, it does happen where people find easy solutions. I had a teammate, her handle was Lightning, and she was the most masochistic CTF challenge writer ever. She loved inducing suffering. Actually, how many people have heard of middle endianness? Not big endian, not little endian, middle endian. So remember that DEF CON challenge? What was the name of the platform? Clemency, thank you. Lightning wrote Clemency. Just to give you a sense, she is notorious for like just, painful challenges. And back in the early days on like Ghost in the Shell Code, we would only let her field challenges because she inevitably had some other accidentally slightly easier solution. They were still really hard, but there was usually one that she hadn't figured in because her intended solution was a nightmare and no one would do it in time. But thankfully, there was always something that was a little bit harder or a little bit easier. Still hard, still a very tough challenge. But yeah, so like one of the big innovations, one change in CTF that's happened over the years is self-balancing points. And I think it's a huge improvement, right? Because that helps that problem get solved. Like, oh, I thought this was 500 points, but everybody got it, so it's actually only worth 100, which is really helpful. And likewise, if something I thought was easy, but no one found my intended thing, well, give more points to the people who did. Yeah?
Have you ever wanted to find an exploit in some service or software, couldn't find it, and then just put it as a CTF challenge?
Yeah. Yes. Yes, I have. But you can't, so it's a little nuanced. And I should probably repeat questions for the recording too. The question was, have you ever tried to exploit something or had a problem in exploitation, tried to like solve it, couldn't, and you instead turned it into a CTF challenge? Absolutely, and I'm not the only one. I know of 3 other people who have done this with like what otherwise would have been sensitive things. That they anonymized in such a way that they wanted a tool to exist, and they were too lazy to write said tool. And so they released a challenge where if you built a tool to solve that challenge, it would probably help solve some other thing. I know of 3 times that's happened in the last 20 years of CTF. So it's probably happened a lot more, which I think is hilarious. So yes, that's actually one of my spicy notes that you've already uncovered. Fantastic question. All right, so we have 2 pens left. We have 2 pens. There are still pins left. And actually, you can choose a pen or a pin, I guess. Cool. Good questions. All right. So that's, I think, a lot of the CTF and the fun stuff. Oh, I guess, yeah. No, we'll leave that for those. There's our spicy notes. Let's talk about Binary Ninja, intermediate languages, and AI. Oh, is it off the screen? Yes, you guys can see that. That's fine. I got to make sure I don't pull up customer files on stream. So let's see here. When we built Binary Ninja, like I said, we really wanted to focus on making the product have a better API. Also, just like the UI and UX was something we were really passionate about. We don't always get it right, but we argue about it a lot, so hopefully that makes it better. I think that's how that works, right? Okay, so yeah, let's talk about this stuff, which I don't know. I think the CTF stuff is just as interesting. Oh, here's one of the things I wanted to mention too. So I'm assuming many of you are looking at careers in information security or in cybersecurity, right? And so I think there's a lot of unknown right now with like AI in particular. Like, how is this going to impact the field? Somebody told me in 2002, maybe 2002, 2003, somebody who had kind of been around the security community longer than I had, he said, Jordan, get out of this industry. Microsoft is introducing DEP. Like, it's over. All the exploits are going to be dead. Like, what are you doing, man? Like, Microsoft is going to, like, they've got this, like, letter Bill Gates wrote. They're going to, like, get really serious about security. They have all the budget in the world. They're going to come up with secure software, and no one's going to have a job. Security is going to be solved. Like, and he meant this. And he was a smart guy, too. I want to point out. This was not somebody who was, like, I really respect his opinion, but I thought he was crazy. I was like, are you kidding? There's no way. There's no way. And I think, obviously, in hindsight, we've had a lot of security problems since then, right? So it was not the only, turned out we didn't just need executable stack buffers to be able to exploit software. There is CFG now. Oh, it's gonna solve security. No, it makes it a lot harder, right? Control flow guard. There's a lot of protections that operating systems and compilers and languages are building into software, which are really good because that makes the software better by default. Because if you require developers to do something different with their code, that's like a losing strategy, right? Like you're not gonna like get developers to like learn how to like not write buffer overflows if you give them pointers. Like it's just not a thing that's really gonna happen. So you either have to have tooling to help them or you have to build systems around them to like mitigate the risk. So I think this has a parallel nowadays because I do think that AI is going to impact the industry in a bunch of ways. And we don't really yet know what they all are yet. Like we're still figuring that out. There's like the hockey stick part of the graph. The technology hasn't, like the rate of improvement in LLMs in particular is such that like we're not sure when it's gonna stop and what it's gonna look like when it does. But when it does, I'm very convinced there will still be a security industry. And it tends to only grow. So I think it is generally a really good field to be in regardless. And part of the reason, actually, I talked to, yes?
The question is, why is there so less interest in cybersecurity in general? I mean, there is a ton of job listening, but in this university alone, the module cybersecurity is getting phased out.
Really? I didn't know that. I hope that's not an overall trend. I don't know if it is, yeah, I don't know why it would, because again, to me, it seems obvious that we need more than ever. When I worked for Raytheon for many years, after a while I got moved to management. That's why I went to go start a software company and build Binary Ninja, because I wanted to be technical again and not like just go do recruiting and hiring and stuff. And like, yeah, we always had permanently hiring. We could not find enough people that could do reverse engineering, that could write exploits, that understood like, just good with computers was the word that we used, right? A lot of people are good at like building applications, but to be good at security, you have to be good with computers. Like you have to understand how they work. You have to understand the software sometimes better than the person who wrote it in many ways. Like you have to really just understand how things are connected, and then you can understand the relationships and why things are messed up. Whether that's between a piece of software and an API it's using, whether that's internally to the software of how it's manipulating things, whether it's in a network and a collection of systems, right? Like vulnerabilities exist at interfaces usually, like between one thing and another. And so that's another reason why Control for Guard and NX and stuff will never solve all bugs, because many bugs exist purely between one piece of code and another across some sort of defined API boundary, and they're just purely logic bugs, right, that are just the way that we're using software. So like we're not getting rid of the computer is not psychic and doesn't understand what we intended, although we'll see with LLMs if maybe they'll get better at that. But that just means we're going to use LLMs to attack the stuff too, right? So I guess to answer your question, like I hope that's not true and that it's only a localized phenomenon, but I don't know. I do see like a lot of hiring in general in security. And it's also, again, security is a big field. Forensics, incident response, malware analysis, vulnerability research. So it depends kind of what and where. But yeah, I am disappointed to hear that. That's unfortunate. If I can lobby and vote for it, let me know. I'll write a stern letter, and I'm sure they'll care. All right, so pop, where was I? Somebody to remind me, what was I? Normally I'm pretty good about tracking this stuff, but I've got... Yeah. Is AI going to, like, how much is it going to change, what it's going to do to the community? But because, again, the community went through, like, a fairly serious upheaval. Like, format string bugs died almost overnight, right? We really did kill most format string bugs, with some exceptions for a few embedded kind of situations nowadays. Generally speaking, like, format string bugs kind of died because we modified some libraries, we built, like, that you can statically analyze and scan for it. So there's, like, big changes where, like, classes of bugs generally die, but, like, new ones come up. Right? So I just feel like that it's not going to go away. And the reason it's not going to go away is because, with very few exceptions, most of the jobs in the world are competitive or collaborative, but they're not antagonistic. Right? So with the exception of like maybe police and military, where there's an active human that you are aggressively, exactly antagonistic towards, Security is like that. There are human beings on the other side of security actively trying to defeat what you're doing, or you're the one trying to defeat what somebody else is doing, right? It is fairly unique. There's not a lot of careers, and there's careers where you're trying to like sell better than the next guy, or you're trying to provide better service than somebody else, like you're competitive, but you're not antagonistic. My doctor doesn't want the doctor next to him to fail at his job. That I would hope not, right? Like, there's enough room, we all need doctors, and that's okay. In security, the defenders want the attackers to fail and vice versa. This is really weird, right? This is a strange kind of like economic environment. In fact, there's a lot of like, economics is a great second major to go with cybersecurity, by the way, because a lot of security is about risk and analysis and mitigating that, and about even incentives, right? Why is ransomware so popular? Because it makes money. Why do you rob banks? That's where the money is an old joke, right? Ransomware works. They're making money on it, and so they're going to keep doing it while it keeps working. Because there are actual human beings who are profiting, and for either monetarily or for intellectual property reasons or for patriotic reasons or all sorts of other reasons. There are people who are trying to combat your code. So I think that's the number one reason why security as a field is not going away. All right. That's just me on my soapbox, just making stuff up. Let's get to the more interesting stuff. So I promised source code. I don't know if it matters, but here's the Binary Ninja source code. I say that's a boring one, but we can pull things up. So if we have questions that require looking into the product, especially people who've used it, if you've got questions, I mean, we're also pretty open. So somebody put out a funny meme several years ago, which was a four-quadrant kind of chart of sort of Libre and commercial, and then draconian, I forget the exact phrasing, and sort of chaotic or free or like anarchist almost. And it was like, Ghidra is free, it doesn't cost any money, but it's produced by the NSA, right? Hexrays is commercial, and it's produced by Ilfac, whom actually I like and get along with quite well, but like he's not the most open about how he conducts things and does things, right? Binary Ninja is commercial, but is technically like a good chunk of the product is actually open source, right? A very large percentage of it is actually open source plugins. It's extensible. We're very transparent. You can see our entire product roadmap. And then I think they had Redare in the other quadrant as, is that what it was? I forget the last one was a little bit more of a stretch, but it was basically, yeah, I think it was Redare, because Redare is both free and also free, right, in both senses, a little bit less than maybe, although Ghidra actually is, I think, fairly trustworthy as an open source package, and I think in sort of the spirit of open source, despite the NSA scaring some people away from it. I mean, I'm fine if people want to get scared by it and not use it. That's okay with me. You can give me money instead, but I don't think it's necessary. All right, so Binary Ninja. How many people have actually used Binary Ninja before? Okay, not a ton, but good chunk of the room. And there's stickers for you now, so you can rep that to the world. Let's see, which one do I want to open? Let's just open a piece of malware. So here's an existing database. Oh yeah, so this is a piece of ransomware. I think this one was actually, this may have been Tiny Turla, which I think was a malware sample attributed publicly to Russia, right or wrong, during the early days of the Ukrainian invasion, where it was a ransomware that was just a wiper, right? So it's called a false flag operation is a term that gets used, where basically like you want to either pretend to be somebody else or you act like you're doing one thing but you're really doing something else. It's much more common in like the intelligence and military, kind of like they're thinking all this kind of crazy stuff. And so this one claimed that it like send your Bitcoin here and we'll unlock your hard drive. No, there was no unlocking your hard drive. It was just meant to like ruin your hard drive and ruin your day, but make it look like they messed up and lost the Bitcoin wallet or something. So that's this particular sample. Here's Binary Ninja. I don't know. Like is it interesting to like talk about like this? Do you want to talk about the intro? What do you want to talk about? Do you want to talk about the Yes? Question.
I'd like to talk about how long, or as a whole, the process of getting to know the instruction set for specific hardware and
Yeah.
writing the code that actually decodes opcodes from this instruction set into readable, what's it called,
disassembly, mnemonics. Yeah. Okay. So actually, has anybody seen, this just got released like literally 2 days ago, I think, well, publicly. Decompilers.wiki? Decompiler.wiki? One of the two. Yeah, there it is. Decompiler wiki. So Zion Bask from ASU just posted this. And I think this is a really, really good resource because it not only links to a whole bunch of academic literature on the state of the art of decompilation, but it also talks about like overall the steps of it. Like there's several distinct steps in building a decompiler. Step one is you have to like parse the bytes into something meaningful, right? Most of the time you're given just raw native bytes. Sometimes you get something like .NET or PYC where it's like virtual opcodes, but there's other metadata associated with it that helps. But even like an ELF or a PE or a Mach-O file has metadata in there. For example, Mach-O files give you all of the function starts nowadays. This is great. And they do it for control flow guard reasons where they want to be able to, or not, whatever their, Exergy is Microsoft, or whatever the Apple equivalent is. They want to do it to be able to ensure integrity. You only branch to valid known functions. But from a disassembler decompiler perspective, this is super nice. They've just told me where all the functions are. By the way, one of the hardest problems in computer science is this code or is this data? I've given you a file. At this offset, at this byte, is this code or is this data? It seems like a relatively easy question, and it is one of the hardest things. Like, you open it up in Binary Ninja or IDA or Ghidra, and they just give you an answer. And they're right most of the time, but it's a heuristic. This is a best guess, and it is impossible to know this perfectly. We sort of take for granted a lot of the times. There's a bunch of, I sort of have a joke that I make that a lot of academic papers are like, assuming we start with this, and they all like skip the hard part, and then they're like, which is fair though too, right? To be clear, in an academic paper it's fine as long as you're usually scoping your problem to just part of it. You can't solve everything. And so this is perfectly reasonable, but oftentimes they really gloss over like, oh, you just start with this, and then we do all this amazing stuff. It's like, well, yeah, but like you stood on the shoulders of giants here because you had to like solve this part of the problem first. There's a lot of reasons why this is the case, but I just think it's a funny thing that if you haven't really dug into it, you sort of assume that that would be relatively easy. Is this a function? Is this some data? There's actually a lot of edge cases that can make that super hard at the extreme. So, but like you want to take that byte, assuming it's a code, and you want to start disassembling it, and you've got to now decode the opcode, right? And so a couple of key things about the way that we do it in particular, for example, no allocations. You should never allocate when you're doing disassembly. You should use fixed size buffers and just for performance reasons. So that's one minor thing. Oh, all of our architectures, by the way, are open source. Actually, we just moved them into the other repo. So we used to have them in separate repos, but then we moved them into here because we were tired of submodules. Submodules are the worst, except for sometimes all the other alternatives. So let me make the font a little bit bigger. So here's all of our actual architectures. So if you want to see how we've done our x86 decomposition, you can look at it through here with, like, there's a ton of enums. And we're actually using Z in this case. So we gave up, right? We cheated. And we do this like a couple of different ways. We actually used Capstone for one of our architectures. We use Z for x86. Now you still have to then parse out all of the Z decomposition into whatever you want. But I would highly, if you're writing your own disassembler or decompiler, I would highly recommend not for x86. Just use Z. It's made by Intel. It's relatively well maintained, and it has done most of the hard work for you. That said, yeah, there's a lot of ways that you can do it, but usually it depends on like how the architecture itself is configured. But usually you're going to mask off the bits that for the opcode. You're going to look up in a table of entries where you've actually got all the different extensions or parameters, what you're going to need to do. x86 in particular is hard. How many people like know the short? Not you, because I know you know. Most other people should know this. What's like the most obvious difference between x86 and ARM in terms of making it hard to parse out instructions? Yes? Wait, hold on, stop. You already gave it away. No, I was going to let somebody else talk, but go ahead. Yeah, exactly. Variable length instruction codes, right? So x86 can be, give me a single byte x86 instruction opcode. A single byte, yes. 90 is a NOP, which is, what's another way of you know what that 90 actually sort of originally stood for in the opcode space? So a lot of opcodes, by the way, are logically organized. So 90 actually is it move or XOR? Oh no, I've forgotten. It's move. It's move with EAX, and then the last 3 bits represent the source register you're moving it from. And because the register order in x86 is EA, EC, ED, EB, I know it's not alphabetical. I don't know why. Go complain to Intel. But the order of the bits is like EAX, EC, or R, depending on 64 or 32, EA, EC, ED, EB, EBP, ESP. I may have gotten those back in ESI, EDI, right? Like the exact order is not important. I used to remember this. I'm getting old, right? But the cool thing is, if you just memorize those 8 in order, 90 is move EAX with EAX, which is why it's a NOP. 91 is move EAX, or exchange. Oh, it's exchange. It's not move. It's exchange. It's exchange EAX with itself, which is why it's a NOP. So exchange EAX ECX would be EA, EC, 91, right? So hex 91. So you now know 8 opcodes. Yes?
Oh, I just wanted to provide you a 1-byte operation that actually makes sense, such as add counter AL immediate 8.
Well, yeah, well, so that's a 1-byte opcode with an immediate, right? So the opcode, yes. So there's different ways I phrased it that you could interpret it a different way, right? That is a 1-byte opcode with an actual argument to it, right? And some of them have arguments, some of them have different length arguments. Some of them, the argument length is encoded in a couple of bits in the instruction. And then there's like there's a bunch of annoying things about x86. You can also have multiple valid encodings for the exact same instruction that are different length. Just because why not? They had some unused space, and so they repeated it. Or like they wanted the really short exchange EAX, ECX, but there's also the longer form of the exchange EAX, like, I don't know. Like x86 is atrocious. But yeah, I recommend using something else. So we use Z. That's how we do it. And then, so back to the decompiler wiki, though. I think this is a really good point, because the first step is actually decomposing, taking apart the bytes, turning them into some structure, some mnemonic, something that you then will do further optimizations on. So we translate the disassembly into an intermediate representation or an intermediate language. Does anybody know the difference between IL and IR? No, really, because I don't know. So if I mean, I have one explanation that Peter gives, but I don't know if I agree with it. Peter would say an intermediate language is a language and has, like, languages have properties like completeness, whereas an intermediate representation need not be complete. I think that's overly pedantic, and I think it doesn't matter. So I use them interchangeably. Most people will kind of swip back and forth with an intermediate language, intermediate representation. I don't know. I leave that to people smarter than me to debate. But I'll do both. So this intermediate representation is literally just, it's some bytes that are not native. They're not for a CPU. They're for some sort of, like, almost you can think about like a virtual machine, right? So you could think about .NET. CIL is an intermediate language, right? Like that's where their whole abstraction is the source code goes to an intermediate representation, and they're sort of done. That's it. They ship it, and then you run an emulator across it on the. You can JIT and you can compile. You can ahead of time compile. You can do all sorts of things to make it faster. But they're sending you this intermediate representation. JVM is the same thing. The JVM is an intermediate representation. It's not native, well, except for Giselle. There were actually CPUs made to run Java, but that was crazy, and we learned that. That was a mistake. Java was just way too, it was the craze of, we like to forget that happened. Let's just not go there, all right? Poor Ghidra. The intermediate representation is something between the native CPU, right, and further on. Binary Ninja does something distinct where we have a whole stack. Sergey Bradas likes to call it our tower of IRs. We usually say just a stack of IRs, where we have from the machine code to this low level, to a medium level, to a high level. And that's actually a lie. It's a convenient lie, but it is a lie. There's actually a lot more than that. So really, it's this many. And now we even have like pseudo C, which would just take the high-level IL and format it as C, so do C-style syntax, put semicolons or braces, but it's pretty much still just the high-level IL. So each one of these becomes more and more abstract, right? So further away from the literal bits that CPU runs, all the way up to like source code that a human would read. that you would annotate, right? And there's different properties that each of ours kind of have. There's SSA forms, which if you want to ask questions about, I can answer, but I don't recommend it. It is what it is. So this is just notation on how to kind of read the IL. But this was important. This is kind of how we designed it. Ooh, yeah, questions.
What would you say, how much would you profit from looking at, for example, LLVM backend part? How much information is lost when it's translated or compiled then to bytecode? Is there some techniques where you can just reverse engineer and do the inverse?
So that is a very good question. And let me see if I can Google it. Otherwise, I'll have to switch tabs to something else. Yeah, I'm probably going to have to pull up this browser. Let's see if it's spicy. Nope. OK, good. There we go. OK. I'm glad it was my history. I didn't have to go randomly browsing my Google Sheets. It probably would have been fine. Oh, actually, you know what? I could have pulled up the GitHub issue. This is a list of, you probably can't read it. That's OK. This is a list. Actually, if you go to the decompiler wiki and check I'll remember your question, by the way, just in a second. You don't have to keep your hand up, but thank you. The decompiler wiki actually has an issue where I link to this so that if you go there and look at their GitHub, this is a list of every intermediate representation that's used in security that I found, and this is just the ones that use LLVM-IR, right? So I had a whole separate slide just for all the things that specifically went from the native bytes back to LLVM-IR, right? But I think even LLVM-IR now actually has an MLIL. They added their own medium level, and it's like the same acronym as ours. It's hilarious. But we had it first. Or MLIR, yeah. The problem is, among others, there's a couple different ones. LLVM is a really bad target to go from native to LLVM. Going forward, as a compiler, for example, LLVM-IR has type information. Compile that to native bytes, poof, most of that goes away. Like you have a little bit of type information at the native assembly level, right? Like you have, this is a pointer because it was dereferenced, so I know it's a pointer, right? But there's no difference between a string or a character array of 8-bit bytes. Like you don't have this type information. Floating point, okay, maybe you know a little bit about floating point. You might know some things because the CPU treats things differently, but you actually don't generally have type information. You certainly don't have structures or anything like that. You just see like pointers and math and offsets, and it could be an array, it could be a structure. Like you don't know that at the CPU level. And the problem is to go to LLVM-IR, you have to recover some type information or make it up or provide it. But that's like the chicken and the egg, because you want to be able to do your analysis to generate type information on an IR. But the whole point of going to medium level or LLVM is so that you have an IR so you can do an analysis. So you have to like make a version of it, but it doesn't have type information. And so I don't recommend it. LLVM-IR makes a fantastic second stage. So lift to one of these first, do type recovery on it. There's a whole bunch of literature on just doing type recovery. It's one of the hard problems. It's going to still be a best guess and estimate. And then take your IR or IL and translate it to LLVM, because you can get a whole bunch of cool things like re-emit it, recompile it to a different CPU architecture, or you can apply a whole bunch of LLVM analysis passes and find bugs and do neat things with it. So it's a great like sort of second stage, but I generally don't recommend doing what all these people did. I don't recommend doing that. But some of them do and have gotten some mileage out of it. Yes, sir?
As I understood, you have this like stack of, let's say, 10 progressively higher level intermediate representations. What do you gain from each so many different levels?
Yeah.
What's the actual advantage?
That's a good question. Have a pen. Or pin. There's a few things. One, the translation from machine code to low-level IL is very straightforward. Let's look at some examples. So if I've got disassembly, actually let's do disassembly on this side and low-level IL on this side. So this is the x86 disassembly for this random piece of malware. And we can see move EAX dword ESP plus 2C EAX equals dereference ESP plus 2C, right? LEA, it's just add the two numbers, put them in there. That's really all LEA is. It's shorter encoding of that. Test. Now this one's a little bit different. Okay, now we've actually got an if statement. There's a little bit of changing here. But you'll notice basically these are one-to-one for the most part. With the exception of these two, this test and conditional branch here, this jump equal, which is, by the way, the same as jump 0 if you've done x86 before. In your head, every time you see jump equal or jump not equal or jump 0, or the same thing, right? You're just testing if the 0 flag is set because when you subtract two numbers, if they're equal, the result is 0. And so they're literally, it's the E and the Z flag. You'll see them disassembled differently. It's the exact same E flag in the CPU. So it's a compare, it's a move. Like these are like one-to-one, almost, with a few exceptions. Like NOPs will actually get removed. If you find an XOR reg, it'll get turned into like set of 0, because that's just how the compiler does a little stuff like that. But it's almost exactly a one-to-one representation. So this is fairly straightforward to implement, right? As when I'm writing a plugin for Binary Ninja to support like a new architecture, this is what I'm responsible for. I just generate this. I translate, and again, we can pull up some source code, and you can see it's like a one-liner, like switch case, add instruction, just return, add the two parameters, right? It's like very straightforward. But that's not really great to read. That's basically just disassembly. Although it can be nice if you don't know the architecture, if you don't know the exact mnemonics of like, well, wait a minute, what is JNE? Or, you know, maybe you don't know another architecture and there's some weird mnemonic you don't recognize. So I guess it's kind of nice to have like a sort of pseudo disassembly, right, in the low level IL. But when I go to medium level IL, on the other hand, now you'll notice, for example, the stack is gone. I don't see dereference ESP plus some offset. I have a variable. We've abstracted away, and we just made variables every time we see stack accesses, and we've made a guess. We might be wrong. It might be something is actually a bigger buffer, and we see multiple accesses, or there's a best effort here. We can actually see kind of in Binary Ninja's analysis what it thinks is going on with the stack, and we can adjust it there. But it's much more concise. So now, for example, if you'll see I can select a single instruction, and there's multiple other instructions that are kind of being folded up into this, right? It's being abstracted higher level. However, it's introducing errors, necessarily. Decompilation is a lossy process. You will not have 100%. The only way you can get like 100% accurate is one, it's really small and tiny, or two, you're doing some sort of backfeeding guess and check kind of implementation where you can say at the end, okay, I know this results in the same bytes, and so therefore it's the same thing. But it is not. It is always going to be, I guess, I think an unsolved problem to perfectly recover things. Maybe AI will prove me wrong. But fundamentally, I don't believe this is really solvable. However, you'll see we're getting more and more abstracted. So now, one single instruction has not only the call, but also the setting up of the parameter to it, right? So this load here onto the stack variable is just this variable here. So C2 lower has this parameter C1 coming into it. And sometimes you'll see that actually at high level IL even now, even that'll probably go away. Right? And so that's even getting folded up into higher levels of control flow. So first step is I've got to decompose, disassemble. Next, I've got to lift into some sort of intermediate representation. Next, I've got to recover types. I've got to, or create some sort of representation that abstracts away the stack and makes variables, global variables, local data variables. And then I have to start optimizing, right? Now I have to, and this is the process of decompilation. This is all the steps that we're doing. And then sort of the last one tends to be control flow recovery and trying to model their control flow recovery to match. I don't want to just see while true, check a variable. I want to see it's a for loop, right? Like for loop is easier to understand than a while with an increment counter and a check. Like they're the same thing. For a long time, Geeter didn't actually recover for loops. It just did the while thing, right? And that was just what it supported. So the last step is that sort of recovering these higher levels of control flow, folding, constant folding. There's a bunch of other analysis trying to simplify. Ironically, you're doing what the compiler does when it produces the machine code in reverse to sort of produce a clean output that's readable. Yes?
So you already mentioned many complex steps you have to do to really decompile the binary. But what would you say what was the hardest challenge when developing Binary Ninja, or the hardest problems?
Good question. So the question is, it's going to make me think. I don't think it's going to, I'm not going to give you a pen yet. It's kind of generic, but I like it. I still like it. I only got one left. I got to be stingy now. There's more pen loops, though. The question is, what was the hardest thing? Honestly, the hardest thing about building binary ninja, so there's some hard problems that Rusty solved that I didn't have to solve. We're still struggling with control flow recovery. Right now, he is working on, we had a really simple logical, Boole's law replacement of like A or B is equal to not A and B. Am I doing this right? Somebody who's a better computer scientist than me, right? Is that equivalent? I think it's something like that. Am I doing it wrong? Oh, sorry, I missed that. I did that wrong. Is that better? It's something like that. Give or take, right? There's certain transformations you can make. And so if during decompilation you ever get this, you probably want to display it as this. Am I actually wrong, by the way? Is it out? Yeah, it might be. Is it not the whole thing? It's been so long since I did truth tables. All right. One of the two. There are many rules like this. There are many simplifications that you can make on these representations. And some of them can cause weird results when you're trying to do decompilation in this control flow recovery. Go-tos are a very contentious topic in decompilation. There was a famous paper called No More Go-tos. And then now everyone's like, actually, maybe that wasn't right. Maybe it is. Maybe it's partial. I don't know. And there's sort of like different schools of thought around it. I think that eliminating all go-tos is a bad goal, but generally speaking, the less go-tos you have, usually, yes, the more readable something is, and more understandable it is to humans. So, I don't know. It's interesting. Go read all the paperwork on the wiki, the decompiled wiki. There's a bunch of research on the topic. Yes?
Question about how much influence do different compiler architectures and optimizations have on the whole decompilation and intermediate?
Very little. Very little. We do all of our, and this is an easy one, so I'll finish it before I go back to the other one about the hardest things. I'm still chewing on that one. There are some, but they tend to be like little edge cases in things like our value set analysis. We do actually do value set analysis to try to identify, like when you have a jump table, for example, what are the possible jump targets? And so you're doing kind of like a very simple symbolic solver to try to identify valid, like, oh, it's less than this and greater than this, and it checks, there's some checks. So at this moment, I don't know what this value is, but I know it must be one of these possible values, right? And so then I'm going to create branch targets, add an indirect control flow there for each one of those targets. So we have a possible value set analysis. And what we find is that certain compilers will have different patterns that maybe will exercise a different bug. If our implementation was perfect, this wouldn't even be an issue. We would actually just be perfect every time. Once we go to our intermediate low-level representation, generally speaking, it just shoots right on up and decompiles fairly well. There are a little bits of odds and ends that you have to deal with, but for the most part, we can add in new architectures. The only other thing that happens is there's weird ones like Hexagon, where they do like packetized stuff, where like there's a batch of CPU instructions that like, you've got like delay slots in some architectures that change the order. So there's quirks of different architectures that can be kind of a nasty depending on your model of how you're doing analysis. But generally speaking, a different architecture doesn't add too much of this. Let me go real quick and answer the other one. We'll finish a couple more other questions. I think the hardest part about building binary ninja, yes, there's some hard problems like getting some of these things to work, but a lot of these you can just read the literature, you can implement a thing, and it works or it doesn't, and you tweak it and tune it, and you think about it, and then you kind of get an answer. The hardest part is actually the long tail. It's like the 80-20 rule, right? Getting the first 80% of something is 20% of the effort. Is that right? Yeah. And so like getting 80% of a decompiler is like, yeah, it's doable. Getting that last 20%, getting the quality, the finish, the polish, it's taken us 10 years. And we have now 20 people at my company. A long time, like 50-person years of development in building a decompiler to get to the point that IDA's been at for a while, right? And we're still not there in some ways, right? I think we're better than others. Architecturally, we have some advantages, but like IDA still has better control flow recovery than binary ninja does. Like, we'll straight up admit it. I don't think Geeter does at this point. I think generally speaking, there might be small edge cases, but I would say that like on the whole, our decompilation recovery is a superset of theirs, basically. But there are definitely examples where that's not the case. But IDA, right, generally is going to outperform us. And so it's that last little long tail of like features and like little extra stuff. Like Again, getting most of the way there is straightforward, even if it takes a lot, but like the last little bit, man, is probably the hardest thing. Let's go here, and then we'll go here.
You mentioned AI before. Do you think that machine learning in general could improve this decompilation process? Do you already use it? Do you think in the future it might be
Funny you would ask. I didn't even have to pay him. Yes, that's the next part of the demo. I'll get there in a second. Yes.
Yeah, basically same direction. So, yeah, you mentioned type recovery or recovery of complex types, especially being no problem in decompilation. So, maybe you can talk a little bit how you're using Sidekick for that reconstruct complex structs and types.
Yes. Now, I will have to apologize in advance because I know very little about the internals of that. So really, I can only tell you what's been told to me. And I will probably translate it poorly because I'm not the AI specialist in the company. But there is, so where we're going here is this tool called Sidekick. And I'm going to open Light HTTPD because I like, that is my favorite target to play with. Oh, I didn't want to do that actually. I said yes, I meant no. Jet lag, see? No. Clean database. Okay, so this is Light HTTPD. It's a web server, and it has, it's about 300K worth of code, so it's not massive at all, but it's also not a toy. Yeah, see, you know what? Actually, I have a bug. I want to fix that. I don't like that our size is in hex. Nobody thinks that way. So yeah, 250, 200-something K. Where was I? Linear view. Oh no. Oh, I know what happened. He did this on the plane. Hold on. I knew it. I literally said on the plane, can you make my API key still work? I might have to fix that. I think, let me think about this. So we finally got rid of that. But yeah, you can click to copy here. Somebody had a question just a second ago. Yes? Yeah, it's not the full thing, though. Thank you. I did check that beforehand. Yeah.
Let's say I'm building some cool program and want to distribute it, but people using it need a license, and if it's disassemble it easily or decompile it, I just remove it and recompile it. Or I just don't want people to really know what's going on. How can I make disassembling it, binary I distribute, for example, easier or harder?
Yep. So easier is easy. Compile with debug symbols. And you will give them all of your symbols and all your functions and all your variable names. Is great. That makes my life easier. Make it harder, throw like VM protect on it, right? There are certain pieces of software that are OLLVM, is an obfuscating version of LLM, that just exists to make the life difficult of anyone doing reverse engineering. Say they do a whole bunch of things like opaque predicates, which is where there's a branch in code, a static analysis tool like Binary Ninja, when it sees a branch that says jump if equal or jump if zero, go here, right? Like either it continues execution or it jumps somewhere else, has to sort of like analyze both paths. An opaque predicate, basically just opaque, you can't see through, you don't know in advance where you're gonna go. An obvious example would be like XOR EAX, add EAX some number, sub EAX some number. The compiler knows exactly what the value of EAX is. If it puts a conditional branch here, it's only ever going to go down one of these paths. But a static analysis tool may not. And so it may have to now analyze the code at both places. And if one of them is junk or goes to goes off into like other bits of data, you can slow down the performance. That's a very simple example. There are much more. That one, Binary Ninja will actually solve that one, just kind of out of the box. But there are other ones that are harder to do. But there's also just like commercial tools, like I said, VM Protect is one of the more well-known ones, that essentially modifies, usually not the whole program, but like the parts that you care about, the sensitive stuff, and wraps it in a virtual machine. So now there's a whole virtual machine emulator on top of your compiled code. So it's slower. You wouldn't do this with like the entirety of a video game, for example, but you do some core logic, some license checks, some pieces of it, and then you throw on some anti-debugging techniques. There's a bunch of techniques you can do to make it like where you can't debug a binary by like debugging yourself, by checksumming yourself and checking for, like, if somebody sets a breakpoint in a debugger, it's going to write a byte of into the memory space. And so if I'm constantly checking my own memory addresses, anybody who modifies me will change the checksum, and so I can say, I'm being debugged. So there's a variety of techniques that you can use to stop both static analysis and dynamic analysis. Yeah? No. You just pissed me off. It just makes it harder. A determined person can get through anything that you can do. You've given them the code. The code is running. There's nothing you can do fundamentally to stop that, short of like, the TPM chip on your phone. Maybe you could use some shenanigans where it really only ever code runs on that one device because it's signed and unlocked by a piece of hardware that's relatively secure. Like, yeah, maybe you could get away with stuff like that. But generally speaking, all you can do is make it much more painful and much more annoying. But like, if the code is running on their device, the code is running on their device, right? A good example is malware can be as obfuscated, as packed, as encrypted, as modified as it wants. If it's going to do a thing, I can just run it in an emulator and just watch it do its thing. I don't have to statically analyze the code. I can see, oh, it's encrypting files. Oh, it's connecting to this thing on the network. Now, the countermeasure to that would be, well, it's going to try to detect it's in a virtual machine. So fine, I'll run it on a real piece of hardware, but I'll still monitor the network, or I'll put it in a hypervisor, and I'll, like, there's all sorts of like back and forth games that you can play. But fundamentally, once you give the code out, it's doable. But yeah, how much of an effort is it? Yes, in the back. It mostly works fine. Yeah, no, our license explicitly allows you, if you actually click the license and you read into it, somewhere in here it mentions, like literally, you are allowed to reverse engineer Binary Ninja in Binary Ninja. Only if you pay for it. Not that it matters. The free version doesn't give you the same rights. The free version doesn't say it doesn't stop you. There have been, I think IDA does the same thing. IDA explicitly has in their EULA, if you own IDA, you can reverse engineer IDA. And we have customers who, like, just to answer some question will reverse engineer it. They want to understand how IDA was way more common because their API wasn't as nice. It was like a separate API. That you would just reverse engineer the tool to figure out how to, like, do normal things with it. But yeah, you can, although there have been performance regressions that happen because a lot of times people's first thing they test is Open Binary Ninja in Binary Ninja. And we don't always do that ourselves. And so sometimes if there's like a bug we've introduced, like we don't notice it until somebody does that because it's a relatively large, complicated piece of software. So that's kind of happened. How are we on time, by the way? Are we 10 more minutes? Thank you. Yeah, no, that's why I'm asking. Somebody over here. No, you were next. Whatever.
Yeah, just a side note. Do you know about the compiler? I think it was also presented at DEF CON, which only uses the move instruction.
Yeah, Mobfuscator. Yeah, Christopher Domas, who then Intel hired to shut him up because he was doing too many good things. He's been quiet because he's been working there.
You also have a diagram view in Binary Ninja where you can see.
Oh, so yeah, he did. That was a different talk the same year from the same guy. Or no, that was the same talk. He did like 3 talks that same year, but he also had a thing. It was in IDA where it would use the control flow graph to make a picture of somebody. We have a similar one in our feature map, not in. I haven't even gotten to the AI stuff. I got into the AI stuff. But we had another one where you could do. So this over here is our feature map that is similar to IDA's scrub bar, kind of up top. It just shows you code and data and imports and like empty space with like nothing. Although clearly there's something here. So this there's exception handling records. One of my coworkers built something that would put a picture in that, just using the properties of that to do something. Our graph layout algorithm is different. So if you open up one of those things that has an IDA, if you zoom out and it shows a picture, it won't do it in Binary Ninja. You could theoretically do it in us too. It would just require a different kind of layout technique. That's a funny one. So this is, yeah, I don't want this one. Let's get rid of this. Let's go back to this one. Connection state machine. So let's see if it works now. If I've fixed the API key. This is me using Sidekick. Sidekick is a new commercial add-on to Binary Ninja. So it's like a paid plugin, so I apologize in advance for the shilling that's occurring. But we are like, actually good chunks of this work for free. without any of the AI stuff, right? So we have a server that has several different machine learning models, like some natural language classifiers. Some are backed by both like ChatGPT and Claude, and like several different API backends, several different our own local models. And then we have the plugin. The plugin you can just get in the plugin manager. For example, my favorite, to answer your question about structure recovery, we are going to put this online, but like the structure recovery is in the free one. We don't really tell people this, but it totally is. It's even in the documents, documentation, if you read it. That's arguably one of the coolest features, and then you can get it for free without paying, by the way. I'm sorry, to my coworkers. Because that's actually, we actually ship the system that does that in the plugin right now. What it doesn't do, what does need the online model right now, is this componentization. So turning this function and identifying all the related functions is something that our online model does, and where it actually puts everything into a component group here. And once you've got that, then it's able to do structure recovery across all of those items in the component. But you can manually create a component, put a bunch of stuff into it, and be like, recover structures. And Sidekick will do that offline just fine, like right now. Just by the way, for those of you that are interested in this. And so let's go look at the structures it just made. So we've got a lot of, actually, let's drag them over here. Yay, 4.0. No, wrong one. This one. So it's made a whole bunch of structures, and you'll see there's structures with pointers to other structures. Although that was a pretty boring one. That really should just be like probably a character inlined, or char star. But yeah, there's some more complicated ones here, right? Like this one has, yeah, it's an actual structure inside another structure. So it's basically creating a whole bunch of structures. And you'll notice it doesn't know what all these fields are. Like it doesn't know what they are. That's fine. It just leaves them kind of blank and it puts question marks. And you can come along later and you can actually like add a type there, or you can like, you know, change the like the C representation to modify the type. But it's created these for you. It can also, yeah, the dead store elimination thing annoys me. I don't really like that. It will also name things, and so this does use the LLMs. Oh, someone earlier, we were talking about this, like how much can AI do? They're really good right now at plausible names. Notice I didn't say accurate. I said plausible. Most of the time they're accurate too, and they're very plausible, but also sometimes they just make stuff up. However, on something like this, where you've got a lot of context and you've got some imports with symbol names, maybe you've got some of the functions that are named locally, no variable names, many of the functions that are not named, they do pretty well. They can infer context from that and come up with decent names. And so literally just letting this thing run and saying, yeah, like just do your thing, like give me a bunch of suggestions, make suggestions, do your suggestions. We're going to produce like decompilation that is significantly better looking than otherwise it would be out of the box. So we've got this is error field. Like, let's see, why is this called is error? So we have to go look. Well, first it's a flag that's being checked here. We're pulling it in for, oh yeah, there's more names. Yeah, just go ahead and name all the names, right? So just keep letting it kind of name stuff. You notice it pulled out this connections.c. This is a log error write API. This is the line number of source code, I think, by the way, here. Oh, now it wants to give me a summary. It's going to give me like this, plain text comment summary of what it's doing. Sidekick itself, you can go watch. I've got live streams online where I really dig into the features of this if you're curious. There's a bunch of other things that it does. My favorite is actually not even AI-based. It's this feature called the function indexer, which is just useful for finding things, and you can write code to search for them. You can also ask it in plain English, like, please write a script that finds this, and it will write code. And about 60% of the time, it just works, and the other 40%, it got you like most of the way there, and you got to fix the code, but it wrote a pretty good starting point for you. Like this one is actually broken because, it's not broken, it's just the way that our ILs work, they're nested. It's a tree-based expression, and so you actually have to visit the sub-expressions. Although there is a really nice visitor class in the API now called Traverse. It's not the visit one, because the visit one was bad. We had to throw it out, and we got a new one. It's called Traverse. It's better. Anyway. So there's a bunch of other features that it does, but the AIs in particular are really good at coming up with plausible names. They're really good about like something that they've been trained on, recognizing and then like filling out the context for me very quickly. So it's like a super powered version of Lumina. Lumina is IDA service where like if other people have found that exact function before and added names or types and they've submitted it to a server, you can query basically like a fingerprint of that function and get back these names and types, which is super nice if people have done it for that exact pattern, but it's very brittle. Like it's like that exact thing, not just like a slightly different recompiled version of the same thing, nothing, right? And so these machine learning models are more flexible and better at like matching that stuff. So that's what they're good at. But like the LLMs are not great at structure recovery. We have a different model that we do for that, right? There's different pieces that are good for different things. And so I think right now, again, we're on the hockey stick. We're still trying to figure out when are LLMs, when's the current state of AI explosion, when's it going to slow down? And then we'll be able to step back and say, okay, now we know for now what these things are good at, not good at. They're just moving so fast that it's hard to even evaluate them. Because by the time you do, there's a new model that now is 1.5 million token context window. Google this week released a blog post where they're like, yeah, we just took the entire source code to this piece of malware as decompiled by hexrays, shoved it into our model, and asked it what it did. Or no, not even decompiled, disassembled. They took the disassembly of an entire binary and tossed it in. I think it's wrong, by the way. I'm trying to get the same sample. I think they actually are wrong, and I really want to look at this because it's they think it's a piece of malware, but it's in like a game modding scene, and I feel like it's something that hooks another mod, which may or may not actually be malicious. It might just be a thing that is like a mod for a mod. So I think that'd be funny if Google itself is wrong in their blog advertising how cool this thing is, but wouldn't be the first time. Other people have done the same thing. They're like, look how cool the AI is. It shows us all this stuff. And I was like, it gave you a stack layout diagram that was objectively incorrect. Like it switched stuff around. So be very careful learning from AIs. Like they're super useful. I use them for code completion. I use them for things. But things that you can't verify and vet, just be careful, right? They're super useful, but also there's still errors. I want to say two last things about kind of AIs before we end up. Decompilers 20 years ago, 15 years ago, a lot of people didn't use because they were inaccurate. They were just wrong a lot, and they would be misleading, and it was like more of a net negative. And a lot of the old school hackers for years were like, I would never use a decompiler. I only use disassembly. I stare at the raw hex, right? Like there was this resistance to using it. At the beginning was kind of founded, and then there became a point where you're just an idiot if you're not using it because they're so much better and so much faster and so much easier to understand. And so you absolutely should be using them. I think we're at the same point with AIs. I'm okay if somebody right now doesn't trust the AI because like there's things that are, we're still figuring this stuff out. But it is the worst they're going to be right now. Like now is the worst AI is ever going to be. It's not going to get like, well, unless you believe about like the training set versus like feed. Yeah, there's some arguments you can make. Let's skip that for the moment. Generally speaking, this stuff is only going to get better. It's only going to get faster. It's going to be able to run on commodity hardware and need less, like your phone is going to come with it. Your laptop's going to come with it instead of relying on some cloud service. So I think there is absolutely, it is the future of a lot of things, and a good chunk of reverse engineering is going to rely on it. We'll see where we end up. Any last questions? Yes.
When decompiling and making decisions, do you, like in the way you structure the decompiler, do you prefer accuracy, so like being close to what the actual source code was, or to understandable?
Okay, and even that I'm going to quibble with. Yeah, that's a really, really good question. There's my last pen if you didn't already have one. Fantastic question. What is the most important priority for your decompiler? And even accuracy is ambiguous. Accuracy to what? And when you say, does it match the original source code, do you mean when I compile it, it will produce the same bytes? Do you mean it looks in the formatting and the style of the original source code as much as possible with similar names and similar like control flow structure? There's actually different metrics. Originally, hexrays was not a security tool. All right, like the stated goal of hexrays in the beginning was source code recovery. They were a forensic tool for you're a company, you've lost your source code, you have a binary, you need to recover it and recompile it. And so they've really focused on getting their output to be recompilable. Like that was a stated goal. That was the usage. Ilfak used to say, hexrays is not a hacker tool. Like, yes, it is, man. I'm sorry, but it is. I think these days he's on board with that. He gets it. Most of his customers, I believe, are probably hackers or similar, right? And I mean that in both, senses. But like that was the original goal of it. And so like certain design decisions on how you do decompilation, we specifically don't care about recompilability because this is my default view. That's not C. You can't recompile that at all. We focus on understanding. We think the main goal is to be understanding. We do want to be accurate, but it's a trade-off. In fact, we literally right now, this last couple weeks, have some evaluations that we're doing on the simplification, the Boolean simplification I was showing you earlier. We're playing around with implementations of that, and we actually built a little control flow recovery fuzzer where we just emit a whole bunch of random things to see what happens. Also, we were breaking all the other tools. It's hilarious. We broke our own too, and we found a bunch of bugs. And it's like, well, we can make this change. What happens to both readability and understandability, and what happens to accuracy? And like, if one goes down but the other goes up, is that better? Is it worse? Like, at what rate? There's also like performance. What if it's slower, but now it's more accurate? Well, how much slower? Like, there's a lot of like, there's several different like knobs and dials that you kind of want to have, and you sort of just when you're designing a product, there's no right answer. We tend to go for readability. Yeah, I mean, I want it to be accurate, but if I have to sacrifice a small amount of accuracy for a big improvement in readability, I'd probably do it personally. Not everyone agrees with that. Some people really want accuracy, but then like you're going to suffer when you're totally unreadable in a lot of other, So it's there's no perfect answer. It depends on your kind of goals. Okay, I hear there's beer. Oh yeah, friendly.
Would you valid pseudo-state view if anything didn't combine to it? Like, was the internal view of the company pseudo-state view was not really needed? So I remember when it was introduced, and I wasn't sure what the internal reaction to it was.
So for yeah. Pseudo C is our C-style output. And you'll notice here, it added braces and semicolons, and then I crashed Binary Ninja. That's a QT bug we're hunting right now in dev. So clearly we don't test pseudo C much. Pseudo C just changes the representation a little bit. And yeah, internally we were like, why do you want this? This is not the point, right? But for some people it is. And I say, part of building a product is learning when you're wrong, and that's one that I think we got wrong. I think our customers are wrong in the sense that we are right. They really want high-level IL. And like certain people get it, and they've used it enough, and they're like, yeah, I'm on board, I get it. But for a lot of people, that was a huge stumbling block where they couldn't use the product because their brain was so wired that like they didn't see a semicolon and they freaked out. And so it didn't say C. It didn't look like C, and they're like, I could never use it. And I'm like, but high-level IL is better. It's objectively better. It has several things that make it better, but they wanted C. And I actually think that's more our fault for not communicating better, for not demonstrating, for not even including it earlier. But like, there's a reason that high-level IL is still the default, although people can change it, and some people do. Some people still really like their pseudo-C. Part of the problem now is it's kind of like not as well maintained, and like we don't add as much, we don't test as much, and so should we have even done it? I don't know. Yeah, we regret not doing it earlier because it did help a lot. Like people were like, Binary Ninja has a decompiler now, and we're like, we had one a year ago. What are you talking about? They just didn't see it because it didn't say C, didn't say pseudocode, didn't do that. So, yeah. All right. Well, I hear there's beer out there. Come and get your stickers and pens and pins and all that stuff. Thanks for coming out. I appreciate y'all being here.